Inside a commercial Samsung smartphone, buried beneath the standard Android user interface, sits a self-contained operating environment. The author uses the Termux environment to host a chair-root container, a method used to isolate a completely separate file system from the rest of the phone. This visualization maps the raw file paths extracted from the device, revealing a massive installation. It contains complete X11 Linux graphics subsystems, Qt software libraries, and complex node environments running parallel to the host. Every component for a standalone Linux desktop is present here, running within the phone's user space. The author refers to this custom environment as the Sovereign Architecture Protocol. These thousands of files represent a deliberate decoupling from the host device. By moving all core tasks into this container, the developer has walled off their data from standard Android telemetry. The technical logic for this system is defined in a single file called registry-index.json. The parameters hard-coded into the architecture are highly specific. The frequency lock is set to exactly 174.56 Hz. Below that, a wobble variable is defined as fluid dynamic entropy 0.04. These variables reference cyber-mystic concepts, drawing parallels to Nikola Tesla's 369 frequency theories to dictate how the system handles internal timing and entropy. The project shares the same DNA as Terry Davis's Temple OS, an attempt to translate a deeply personal worldview into a functional operating environment. Our objective is to reverse engineer this system to see exactly how the developer turns abstract concepts like Tolkien fields into executable code. Decoding this manifesto reveals how a programmer can use physical Android hardware to enforce an extreme philosophy of digital autonomy. The structural blueprint for this environment is the GAIES tri-layer hybrid topology. The goal for this base layer is locking silicon harmonics, a process of establishing absolute execution control. The governor node variable defines a direct path to the Linux kernel, specifically the CPU scaling governor. In a standard commercial operating system, this governor manages power consumption by constantly throttling performance based on battery life and heat. This script writes the string performance into that node, disabling Android throttling protocols. It forces the CPU to run at maximum frequency at all times. The haptic node path establishes what the author calls the frequency anchor. The script triggers the phone's physical vibration motor to pulse at 174.56 Hz intervals, creating a continuous physical heartbeat for the system. Layer 1 operates by bypassing Android's high-level software APIs to seize raw control of hardware components. Above the hardware control layer sits the data state management of Layer 2. This architecture rejects standard centralized databases and cloud state management. Instead, a script called registry-core.py distributes the system's state across 60 discrete JSON files to form the sovereign lattice. Layer 3 provides the visual interface through an offline HTML viewport named manifold-grid.html. This HTML file reads those local JSON coordinates directly from internal storage, rendering an interface without ever initiating a network connection. Layers 2 and 3 create an ecosystem where the user remains invisible to web trackers and network-level surveillance. The system's primary self-defense mechanism is referred to as the amnesia state. The technical driver here is the TMPFS, or Temporary File System, mount in Linux. Using TMPFS allows directories to be mounted within the device's volatile RAM space, rather than writing to the physical flash storage. Standard applications leave recoverable forensic data and persistent caches on the hard drive. In this configuration, the moment the device loses power or is rebooted, the entire operating environment and all its data instantly evaporate. This setup removes what the author calls governed square noise, the diagnostic logs and persistent tracking files typically generated by the host OS. Utilizing volatile memory provides a hardware-level guarantee that absolutely no data can be forensically recovered from the device. The final component tying these layers together is the ignition.py script. It acts as the continuous operating loop and the primary heartbeat for the isolated environment. Within this loop, we find a function named resonance.checkBullshitPing. In this context, a bullshit ping represents background sync requests and unapproved hooks from the commercial Android OS base. This script actively cross-references the internal loop against those external requests, acting as a strict localized firewall. It functions as an immune system, actively identifying and ignoring requests from the commercial environment it is hosted on. We began with abstract cyber mysticism and found it grounded in rigorous root-level Linux commands. Terms like trialia motion, torsion fields, and hard light states serve as the vocabulary for a highly functional system architecture. By giving these technical components mystical names, the author frames their code as a philosophical vessel rather than just a collection of scripts. This teardown shows that standard smartphone environments are built on constraints, kernel-level power management and storage persistence that the user cannot easily control. The Sovereign Architecture Protocol demonstrates that achieving this level of isolation requires more than just a privacy-focused app. For this developer, control is only possible by overriding the defaults and seizing direct root-level command of the machine itself.